Okay, it is 9:15 Mountain Standard Time, so we're going to go ahead and get started. I want to welcome everybody today to our virtual open house. Today we will be discussing machine learning, supervised learning, and it's one of our micro-learning courses here at NMSU. I am Lori King. I am a marketing specialist for NMSU Global Campus. I have a pretty eclectic background, but I have entered these micro-learning courses. I have received a couple of credentials, and so I'm excited to be here and be part of the discussion. I am going to introduce a little bit of information. Again, this is machine learning, supervised learning. Enrollment is already open, and the course starts now or anytime you desire to get started. The course length is 8 weeks. It is self-paced. It's 100% online, and the cost is $440. And here is the link for the on-demand course, and we'll go ahead and put that in the chat as well. I'm going to go ahead and introduce Andrew Cedillo. Andrew is our Director of Micro-Learning Credentials, Instructional Design, and he's an immersive learning experience designer and e-learning developer. He is kind of the lead when it comes to all our micro-learning courses. So he's a great partner to work with, and I'm excited for him to dive into our topic today. Go ahead, Andrew.
Thank you so much for sharing, Lori. So yes, my name is Andrew Cedillo. I'm the Director of Microlearning. Just a little bit about microlearning. We provide micro-credentialing for in-demand specialized skills. So a lot of our courses that we are currently offering, the idea behind these micro-credentials is to bridge the gap or even allow you to upskill in areas in which you are looking to do so. A lot of times these micro-credentials may lead to job promotion. It may lead to you even jumping into potentially a entire career field, or maybe it may even spark your interest in pursuing a full-time degree within that specialized topic. The idea behind micro-learning is these are shorter courses. Like Lori had mentioned, they usually go no longer than 8 weeks. A lot of our courses, what they're all about doing is we want you to learn by doing. This is going to be practical skill sets that you're going to walk away with. So you're going to get real world practice by completing assignments that would be reflective of what you would be doing in a job environment. So in some ways, this is really exciting for us because not only are you upskilling in these areas, but you're also able to walk away with content that you can use for a portfolio. So when you're applying for positions, or maybe you're wanting to show justification for why you should be considered for a position, you will now have a portfolio of work that shows that you have learned these skill sets. On top of that, we do award you with a digital badge. A digital learning badge, if you're not familiar with how these work, they basically tell the story of you. They're a different way of certification. In the past, we would maybe, get a certificate of completion. We put it on our walls and, voila, yay us, right? And it's great. But if somebody walked into your office, sometimes they may say like, hey, what does that certificate represent? Or what did you have to do? Over time, you may forget that. But with the digital badge, this tells more of your story. Not only will you receive a certificate you could print out if you wanted to put in your office, but you now have this digital credential that can be shared via link that actually shows what you did to earn that badge. It will share exactly what the badge represents and what you had to actually do. You can send this to employers, you can share this through your social networks, and it's also verified through New Mexico State University. So when they click it, there is verification that you have completed it through us. So we're really excited about offering this micro-credential. As a lot of you know, machine learning is a hot in-demand skill right now, or a lot of people want to know more about it. So I'm going to go ahead and hand it off to the people who helped create this.
Hello, everybody. Thank you, Andrew, for helping us to create this course. And thank you, Lori, for organizing this session for us so that we can share with people what we are working on and what they can learn from this course. Well, first, a little bit about myself. I'm a professor in the computer science department. I joined NMSU in 2010, have been here for more than 10 years. My research area is related to data analysis and data management, put it into our computer science term, we call it data mining, applied machine learning, and data engineering. I myself work on the fundamental computer science algorithms and models to basically they should be needed to deal with different type of benchmark data set. We also try to apply those different algorithms and models to many different application domains. In particular, in the last 8 years, we work on different application domains, including smart grids, the power systems, the high performance computing, and the agriculture domain and environmental sciences. That is a little bit about myself. Andrew, will you go ahead, or should I just directly explain the course?
Yeah, I don't know if Erick, you want to introduce yourself real quick too, as well?
Yeah, so my name's Erick Draayer. I've been in the Ph.D. program here at NMSU for about 4 years now, working with Dr. Chow as my advisor. So I work in the data mining lab, and also my research is in data analysis, specifically time series data, so I actually got my bachelor's at New Mexico State University and went on to get a master's at North Carolina State University, and I came back to get my PhD in computer science here at NMSU. And along the way, I've done a lot of internships. I've had an internship at Wright-Patterson Air Force Base, working with biologists and studying actual human brain activity, neural data there. I've also been a year-round intern at Sandia for quite a while, up in Albuquerque, New Mexico, working with seismologists and statisticians and other computer scientists, sort of applying data mining tech methods in my research there. And so I think that's about it. So.
All right. Well, thank you both for sharing that information. So now what we want to know and why people are here is to learn all about your micro-credentials. So can you tell us a little bit about your path to creating this machine learning micro-learning course?
Sure. Maybe let me start. When we create this machine learning class, basically come from a regular course I generally offer. Basically, my colleague and myself, we have a course called Applied Machine Learning. And when we offer that course, we have many students, not just the computer science student, many students interested in that course. Then we start thinking about creating the micro-credential course, and then we approached to Andrew, and we know that the MSU global campus is trying to create this course for us. Then, we prepare the materials, but when we design the course, we don't want to make it to be a complete machine learning course. We try to separate it to several units. Well, I will also mention at the end, so that people can spend a little bit of time and focus on finishing one component and that they are interested in it. And they may not be interested in other components, or they may be already familiar with the other component, then they don't need to take them. That we partition the machine learning course to 3 units in particular, and this micro-credential course is the one major part of machine learning called supervised learning. And then, of course, supervised learning, what are the tasks? What are the traditional or classical algorithms and models? We wrap everything together. And also we created 2 very interesting short projects for the students to take, with the hope after they finish the project, they will get themselves familiar with all the course materials we discussed in the class. And we try to make the course more applied. Basically, I don't just want to tell you the theory, tell you the math, then you go back and figure out how to make it work. Instead, we try to tell you what is the theory behind. We need to know how the algorithm works, instead of treating the machine learning algorithm as a pure black box. You know a little bit of the theory, but you don't need to design the model and algorithm. Instead, we also introduce the practical language. Here we utilize the Python programming language, how to write the code line by line to make your algorithm work. You can actually apply to your problem. In the beginning, if you're not familiar, you even just copy and paste. Literally copy and paste the code and get yourself familiar. But gradually, you will, after you get familiar with the concept, with the code, you will be able to have flexibility to change a lot of things. And then you can start from there. Also, I try to utilize a textbook that has a GitHub repository with a lot of code that you can take as reference. So that's the path we try to create this course. We have very applied practical content for people to follow, but also you don't just treat it as a black box like tool, and you don't know what's happening behind. You also know what's happening behind that will help you to identify what's the problem if the algorithm doesn't work well. Then, of course, Andrew helped us to put everything together and put it into a beautiful online course. That's how we create this course.
Great. Thank you for sharing that. So what I want to know a little bit more too is I know you're going to be offering this as a stackable credential. For those of you who don't know what that is this would be the first of 3 micro-credentials that would be offered. So the idea is that you would take this course and the other courses would be how you would just continue to grow. And by the end, you would have mastered these specific topics of machine learning. So can you tell us a little bit about why you decided to create these courses? What need do you see right now out there?
Sure. There are 2 major reasons for us to create these courses. The first one really comes from the observation that when I collaborate with people from non-computer science domain, when I mentioned in the beginning that I had some opportunity to work with non-computer scientists. They are great researchers in their domain. They want to try some machine learning tasks, try to utilize the machine learning algorithms. But many times I see that what they do is, they pick an algorithm, they utilize it. But then they don't know what are the other choices. The reason they pick that algorithm, they just occur to know that algorithm. So whether their algorithm is the best one or whether it is a reasonable one, if something happens, what is happening behind, how can they adjust it? Is there any opportunity to improve the performance? Many of those questions are unknown to those researchers. So that's why I said, okay, why don't we have some, a more introductory but covers all the fundamental and classical algorithms so that people know based on what they choose an algorithm. If it doesn't work well, what are the other options they can try? And recently, many people talk about deep learning. Well, everything they do, they try to utilize deep learning models. But when I look at their data, I say, you don't have to. You don't need to make your problem that complicated. So I hope that for this group of people, if they take this course, they will be able to make a more educated decision on what they will do. So this is the first reason. The second reason, I would call it general education purpose, literally. Probably you all heard about the term artificial intelligence, and in particular, the large language model like the ChatGPT comes out. They can help your students to finish their homework by utilizing ChatGPT, right? So that is the advance of artificial intelligence. But many people, when they talk about artificial intelligence, they actually mean machine learning. They don't touch many other aspects of artificial intelligence at all. So I want to introduce this course really to give people a more clear idea about what is machine learning, what is the relationship between machine learning and artificial intelligence, and what are the recent advances, what is the connection between the recent advances and the traditional machine learning. For example, the large language model, they are literally more developed deep learning models. But the deep learning model, particularly, how does how does that connect with the traditional models? It is generally connected with a supervised learning technique. Sometimes it's unsupervised learning technique. So they have very intrinsic connection. But I just hope people don't just talk about the hard terms. Instead, they have some better understanding about what is artificial intelligence, what is machine learning. That's the second reason.
Thanks for sharing that. So real quick too, so you kind of mentioned, ChatGPT and how people automatically think of that, or a lot of people think about that when you refer to AI. So now this gets to me wondering, who is this course intended for? Would this also be intended for those who are just interested in learning about AI? Should they have some type of background knowledge about this type of information before heading in? Can you tell me a little bit about who's best fitted for this course?
Sure. Starting from the background, probably we expect the person who enter into this course is to have some basic programming background, in particular in Python, because this is really applied course. We don't just learn the theory. At the end of the course, we hope you can do your job, right? When you do your job, you need to utilize a programming language. So you need to help yourself equipped with some basic Python programming knowledge. Then that's the first. The second is the theoretical knowledge-wise. Many machine learning algorithms are based on very solid mathematical foundation. So it is best that you have some linear algebra, calculus, probability background, but it doesn't need to be advanced. Well, basically, your college education should be sufficient. You learn the basic linear algebra, calculus, and probability. That should be sufficient. The requirement, the background requirement is not too high. I mentioned ChatGPT, I mentioned those large language models. You don't need to have any of those backgrounds to get into this course. In fact, the 3 units of this machine learning course, we even will not touch ChatGPT at all. But in the 3rd unit of deep learning models, I will talk about a recurrent neural network model that is closer to the large language models that like ChatGPT is based on. But you don't need to know any of those advanced knowledge. You just need to have some programming background, know some basic mathematics. Then I think you will be able to enjoy the course. Well, again, who will benefit from this course? What are they intended for? Number one, whoever you are interested in machine learning, understand what's going on, what machine learning can provide us. Well, I think this course will be helpful. You can take many online courses, like YouTube courses. You can cherry pick some topics. That's very easy. But most of them don't give you a very comprehensive view about what machine learning is, what are the classical topics, what are the classical algorithms. We hope that this course will provide a very systematic and extended view of what machine learning is. And what benefit can bring to you. In particular, I think for the people, if you are working in your job, you have some type of data, you want to analyze your data. This will provide a new angle for you to analyze your data. But again, when it comes to the data, it doesn't mean any type of data, it can do the job. Let's say if you do interview, you just interview 10 people, you try to do some analyze from 10 people's numbers, probably the machine learning doesn't help too much. You still need to analyze the problem and to see whether it is reasonable to conduct some machine learning techniques. Thank you.
Yeah, thanks. That was a lot of great information you shared. So you mentioned a little bit about people being able to do things at the job. So I guess another thing I was wondering, what would you consider the return on investment for taking this course, these micro-credentials? In what ways do you see this helping people?
Well, sure. I want to mention that some of the students in my machine learning class, they are professionals. They are working. They have a job, and they really want to get into the area of which they call data science or data analytics. And that's why they take this course, and at the end of the course, I tell the students, hey, you need to work on a project. And for those professional students, what they generate, they can literally apply the techniques they learned in the course in their actual job, and treat that part as the actual job as even the course project. This is how relevant and how directly useful to their job if they deal with data. And also, well, when they finish the course, they will, for this micro-credential, we will focus on which we call the supervised learning technique. In particular, we will discuss two most traditional and classical supervised learning tasks called classification and regression. And in classification, we will cover 4 very basic but very classical, widely used algorithm called like decision trees, k-nearest neighbors, support vector machines, and logistic regression algorithm and models. And in regression analysis, we will cover linear regression and nonlinear regression. We also particularly want to talk about a technique that can be utilized for both classification and regression called ensemble learning. Some of you may already know, like I know many people use random forest. I don't know why, but many people utilize it. But we will give even a more comprehensive introduction about ensemble learning that include random forest. Random forest is just one method there. Oh, well, with the hope, well, when you complete this course, really, I really hope if you have some data you want to apply machine learning, you can start utilizing these techniques. You should be able to utilizing these techniques to do something, whether you can find something useful or not useful, then that's another story that for that you need to probably spend more time to do more analysis.
Great. And so are there any degree programs that would complement these certifications?
I think so, yes. We do have a professional master's in data analytics program, and that program is managed by the computer science department, but that program belongs to graduate school. And that program actually is owned by multiple departments. Several departments are deeply involved, including applied statistics and the BCIS, business management and information systems, and also like some engineering departments, including electrical engineering, civil engineering, industrial engineering. They all have different courses in that program. And in the agriculture college, we try to create an agriculture minor in that degree program. There are some courses from the agriculture analysis courses, and we also have courses in social science, like social network analysis, and we also have courses even from astronomy. They have some courses for data analytics, in particular in the astronomy domain. So that program consists of 3 core building pillars. One is the statistical foundation. The second one is the programming foundation. The third one, the data management and data analysis. And in the data management and data analysis component, applied machine learning is one of the major course required. Of course, it has a list of more than 20 elective courses that cover different domains. Depending on what you're interested in, you can choose from those courses. So this is the direct degree program that would complement these certificates. Of course, our traditional computer science degree programs, master's degree program, the Ph.D. degree program, even our bachelor degree program, the machine learning course is a very popular course in this degree program. But then in those degree programs, more programming courses will be offered and required as well.
Well, thank you so much for your time today. I guess the next thing I have for you all, is there anything else you would like to share with the audience today?
Maybe let me finish this. I want to just share with the audience that we partition this machine learning subject to 3 units. One unit is called supervised learning. That is the unit that we are talking about today. And the second unit is called unsupervised learning. The unsupervised learning will cover 3 major tasks. The first one is classroom analysis. The second one is dimension reduction. And the third one is association analysis. In most traditional machine learning courses, they only cover clustering and dimension reduction. I particularly managed to put the association analysis that comes from a data mining community to this unsupervised learning unit, because I see that many research probably need that analysis. That is the second unit. The third unit is called deep learning. In fact, deep learning is generally can be utilized for either supervised learning or unsupervised learning. In the deep learning unit, I will cover how to write a basic neural network model from scratch. And because that basic neural network model will cover all the essential components when you try to write a complicated neural network. That's the first one. Then I will also discuss 2 very basic, very classical deep neural network models. One is called convolutional deep neural network models, in particular to deal with images. The second one is called recurrent neural network models, in particular to deal with sequential data, text, time series, anything that is in sequence. So those 2 models. In the future, we may consider extend this to include reinforcement learning, those type of units, but that's not in the current plan yet. In the immediate future, with the hope by maybe middle of August, we should be able to have the draft of the second unit and the third unit ready as well. The recommended sequence of taking these courses are the Unit 1, supervised learning, must be taken before you take Unit 2 and Unit 3. If you are not interested in Unit 2 unsupervised learning, you can skip it, but then you cannot skip Unit 1 if you want to take Unit 3, because a lot of fundamental concepts and notation is introduced in supervised learning. If you don't take a Unit 1, when you take Unit 3 and Unit 2, you probably will feel a little bit lost when we talk about the theory. Now, that is the recommended sequence of taking these courses if you're interested. Let's see, if you're already familiar with the fundamental unsupervised, supervised learning, then you can directly jump to Unit 3 if you want to know more about the deep learning. That is a more advanced topic. I think that's what I want to share with the audience.
Great. Well, thank you so much. So I'm going to hand it off to Laurie to open up the floor for questions.
Well, thank you all for great information. We are going to open it up for questions and answers. I have put the course details in the chat. You're welcome to add a question there, or if you'd like to unmute, go ahead and do so now. We have our course creator here as well as our course facilitator. So the floor is yours if anybody has any questions. Go ahead, David. Good to see you.
Good to see you, Laurie. Thanks for the presentation. I'm curious, from your perspective as instructors and, your contact with, the broader community of computer science, when you talk about supervised versus unsupervised, what would you say is the sort of the core skill that's in demand out there in the market?
That's a very good question. In fact, the supervised task is more for a problem that is very well defined. When we talk about classification regression, we call it supervised because in the data, it has the ground, which we call the ground truth. If it is a classification problem, some of you may already very familiar with this. Some of you may not. I just start from a basic example. I have images. I want to see whether this image contains a dog or a cat. So the supervised learning is based on somebody already labeled this picture has a dog or this picture has a cat. So the data that the people who conduct supervised learning, they are generally very familiar with the data. They already label the data already. It is a very well-defined problem. But then when it comes to unsupervised learning, the unsupervised learning doesn't look very, when you utilize the algorithm, it doesn't look like very deterministic, put it that way. There are so many ways to interpret the result. However, when you are looking at the data, you don't know what is inside the data. You don't know what you want to find. In fact, unsupervised learning is more useful because it really does data exploration more. It helps people to look at the different time, whether I can find clusters, whether I can find some associations. And then based on that, people can do further supervised learning technique. And most of the times, though, it's more like the problem is not directly a supervised learning or unsupervised learning task. The problem is a very undefined, not well-defined problem. What people generally need to do is they need to compose the problem and they need to pre-process the data and convert the problem to a supervised or unsupervised learning problem. I can give an example. Recently, I was talking with a colleague. Some of you may know her. She works on remote sensing images. And she said, I try to utilize convolutional neural network to analyze my remote sensing images. And then I have some further analysis, talk with her. It seems to me she tried to classify each pixel to a land cover, maybe forest, maybe something. But then that problem, from the data to the problem, is there's no direct connection yet. So she needs to cover the problem and properly define, which we call the instances for classification. Her problem can be put into a classification problem, but several steps of pre-processing is needed. Only when we understand those concepts, that's which I call the concepts and theory behind, we can properly analyze the problem and convert it to a data mining or machine learning actual predefined task. Yeah, I would say there are different needs for both type of machine learning tasks. However, most of your researchers' problem, my analysis is you cannot directly apply those techniques. You need to decompose your problem and reformulate the problem and do some data pre-processing, then convert the problem to a machine learning issue and utilize that. And many problems in the real life is like that. I hope I answered your question.
It did. Thank you so much.
Excellent. Thank you, David, for your question, and Dr. Chow for that great response. Any other questions from our audience today?
We received a question before on LinkedIn. So is this course self-paced?
Yes. We already put all the thanks, Andrew, put all the materials online with all the slides, with all the videos, with pre-recorded videos. We also put the projects there. Anything that is needed for the course, you can just follow the flow that is designed in the course. And we have a great facilitator, Erick. He is a very experienced student in this area already. And when you run into any problem, you can send emails, and then Erick will help you respond. When Erick is really not available, I will definitely help to respond as well. And we help you in the process. It's not like you're left alone by yourself. You run into any problem, nobody will help you. No, you follow the major flow, but when you run into any specific problem, somebody will step in to help you as well. Totally self-paced. You can finish in 1 week, or you can finish it in 1 year. I don't think we have the limit set yet.
That's great. And I know from taking my own microlearning courses that you can go at your own pace. And even if you finish early or someone else finishes ahead of you, those conversations still continue to happen with your classmates. And so the learning does continue even after you've completed the course. The other thing I love about these digital badges is they give you a direct link to your social media profiles or your LinkedIn profiles. So it really works out well whether you're looking for a job and you want this extra credential, or even for your current job where it just is a value add to your employer overall. So excited about this opportunity. We have put the course link in the chat. This has been recorded. We will be sending out a recording link hopefully by the end of the week. And any final questions or any input from our speakers today?
Yeah, I would say if you have any other questions after you go back and think about it, well, feel free to send me or Erick an email. We will do our best to respond. Yeah, well, probably some of you are MSU colleagues, so we are in the same campus. Yeah, just feel free to send us a message. Yeah, that's what I want to share.
Great. Well, thank you all for being here today. Thank you for taking time out of your schedule to join us, and we look forward to seeing you in the class.